Hello, we're going to talk about basic algebra. In algebra, we represent numbers by symbols. Quite often, we use letters. For example, if I have a number 5, instead of calling it 5, I would call it, say, A. So I'm representing this number 5 by the letter A. Why is that useful? It's useful quite often when we either need to talk about a number that we don't know, or when we need to think about some ideas that has to do with this number. So as we move along in the lessons, we'll see some examples of this. But what we want to do now is to look at how we can manipulate this number, how we can add or subtract or multiply or divide, and how we write this. So for example, let's make up another letter to represent the number 3. So now I have two symbols, A and B, and each of them represents a number. Now what would I do if I want to add these two numbers? Normally, I can just say 5 plus 3. Now in algebra, we can also use the symbols. We would say A plus B. So A plus B really means, in this case, the same thing as 5 plus 3. If we want to multiply them, we can do 5 times 3. That's multiplying 5 and 3. Or in algebra, we can write them as A times B. So that's using the symbol. Now a special way to write algebra is that we would usually leave out the times when we multiply two quantities. So if we just write AB, just AB with nothing in between, that means the same thing as A times B. But if you are adding them, then you must always write A plus B. You can't just leave out the plus. So this is specially for multiplication. If you have nothing in between the symbols, it means A times B. Now if I want to divide the numbers, I can make a fraction, 5 over 3. That's the same as 5 divided by 3. I can also use a symbol and write A over B. So A over B means A times B. So just as an example, if I need to write, say, 2 times a number that is represented by x. So in words, it would be 2 times x. Now if I want to write this as an algebra expression, I would write 2 times x. Now one point to note is that in algebra, we often use x to represent a number. The trouble with using x is that it looks quite similar to times. 2 times x. and it's quite easy to confuse the times with the x. So for me personally, I prefer to write the x in a curly form, like that, instead of a cross, just to make them look different. So that's 2 times x, and as I've just said, when we have two symbols or two numbers multiplied, or two symbols multiplied together in algebra, we can leave out the times. Now in this case we have a number and a symbol. We can also leave out the times and write it as 2x. So 2x means the same as 2 times x. Now we have to be careful that this does not apply to numbers. For example, if I want to do 2 times 3, I cannot just leave out the times, because if I do, I'll get 2, 3, which is 23. Alright, so 2 times 3 is definitely not the same as 23. So this is just for expressions that contains symbols in algebra. Next, we are going to look at the idea of substitution. Alright, so suppose I have an expression in algebra. Let me call that 2a plus 1. So we call this an expression in algebra, or we can call it an algebraic expression. Algebraic is just algebra with the letters IC after that, algebraic, and that's just an adjective. When you turn algebra into adjective, you say algebraic. So I would call this an algebraic expression, or just expression. Right, suppose I have this expression 2a plus 1. So remember, 2a means 2 times a. Alright, if we have two symbols or a number and a symbol with nothing in between, it means a times. 2a plus 1. A is supposed to represent a number. Now, suppose that I know a is equal to 3. I know that a is this number 3. Then I can actually calculate what 2a plus 1 is, simply by replacing the a there with a 3. Let's do that. That's 2 from above. A replaced by 3 is a 3 plus 1. Now we have to be careful here. If I just write 2 and 3 with nothing in between, that is 23. If we have just numbers, we have to insert the times symbol. Right, and this step where we put a, we replace the a by the 3, this step is called substitution. Right, so once we have substituted 3 into the a, we can now calculate this expression, and that would be 2 times 3 is 6 plus 1, 6 plus 1 is 7. So now we have our answer. Let's look at another example. Suppose we have another symbol here, a b over 2. Suppose we have this expression, and suppose that a is still equal to 3 and that b, let's say b here is equal to 4. Alright, now we can calculate a b over 2 if we know what a and b are. And again, the method is called substitution. All we need is to substitute 3 and 4 into the a and b. So let's try that. So a is 3, b is 4, and since we have numbers now, we know that ab in algebra means a times b. So we need to insert the times sign between them over 2, and then 3 times 4 over 2, that would be 6. So that's calculating expressions by substitution if we know the numbers for the symbol. Next, we are going to look at the idea for powers in algebra. If I have a number 2 multiplied by itself 3 times, 2 times 2 times 2, we know that we can write this as 2 cubed, or 2 to the power of 3. We can do the same in algebra. If instead we have a symbol, say a, and we multiply this by a and by a. So a times a times a. I can write this as a to the power of 3. So that's powers in algebra. So just to, as an exercise, let's do it the other way around. Suppose I have an expression that says 2a squared b cubed. What does that really mean? Right? So that means that we have here a number 2, we have the symbol a squared and the symbol b cubed with no signs in between, and that means they are multiplied together. So this really means 2 times a squared times b cubed. Alright, so that's the first step in the understanding. Next, a squared. A squared is just a number squared, so that should mean a times a. A times a. And then b cubed is a number cubed, a number to the power of 3. So that would be b times b times b. So that's the full meaning of this expression, of this 2a squared b cubed. It means this. And just as an exercise, let's say a is equal to 3 and b is equal to 2. If we know these values for a and b, we can find a 2a cubed, 2a squared b cubed by substitution. Let's try that. So 2, a is 3, so substitute. That would be 3 squared for a squared times b is 2, so 2 cubed. Now we have all numbers and we can calculate the answer. Right, so 3 squared is 9, 2 cubed is 8. There, you can find the answer. We'll now look at adding terms in algebra. Let's start with an example. Let's say I have 2a and 3a. We have these two expressions, 2a and 3a, and we want to add them. So when we add two things together, these two expressions together, we call each of these a term. So terms are the things that we add together in algebra. So 2a plus 3a. The idea here is that we could try and simplify this expression. So what we have here, 2a plus 3a, is an expression in algebra. Alright, and we can try and simplify that. Now just to, if you think of it in a simple way, we might think of 2a like 2 apples and 3a like 3 apples. So if you think of 2 apples plus 3 apples, what does it mean? Can you simplify that? We can, indeed, because 2 apples plus 3 apples is equal to 5 apples. So that's the simple way of saying 2 apples plus 3 apples. And in much the same way, if you have 2a plus 3a, the simple way to say that would be 5a. So we have just simplified 2a plus 3a into 5a. You would agree that 5a looks simpler than 2a plus 3a. Alright? Now that's the simple physical way to think about it. Mathematically, we can also think about it this way. Let me write that down. 2a plus 3a. Now I can think of this as bracket 2 plus 3a. What this means is that if I have a bracket here multiplied by a, then it means the same as a multiplied by each of the number in the bracket and then added together. So this is the kind of thing which we also see in when we do arithmetic with just numbers. Alright, then in the bracket we have just 2 plus 3, which we can add together to give 5. And if we have a bracket 5, it really just means 5. So it's 5a. 5 times a. Right. Now let's take this one step further. Suppose now that instead of instead of that we have 3a minus 2a. We have a minus sign now. We want to subtract the two terms. Right. So using our apple method, if you think of this as 3 apple minus 2 apple, then you know what's the answer. It's just 1 apple. 1 apple. Now in algebra, if you have 1 times a symbol, you can leave out the 1, because 1 times anything is 1 times any number gives you the same number. So 1 times a gives you a. So 1a is the same as a. Right. Or we can do it more mathematically, like I did just now, making use of the brackets, and you'll just get the same answer. Now, when working with such sums or subtractions, once you get used to it, you don't actually need to think of apples or brackets. All you need is look at the two terms, like 3a minus 2b, and you can right away do 3 minus 2. You can just do that directly to get the 1. Or in the previous example, where you have 2a plus 3a, you can just do 2 plus a directly to get 5. So 2a plus 3a, just add the 2 and 3 to get 5, and you get to 5a. So that makes things easier. So then we will now make things a little bit more complicated. Let's do something like this. Let's say we have 2a plus 3b plus 5a plus b. Right, we have a longer expression here, and we have two symbols. We have a and b. We want to simplify this using the ideas that we've seen just now. But how can we simplify 2a plus 3b? It's like adding 2 apples to 3 oranges. You can't just simplify that. And in fact, it cannot be simplified. You can only simplify them if you have the same symbols in the terms. So in this case, what we have is a situation where there are some terms which can be simplified, like if you pick out the 2a and the 5a, you can add them. If you pick out the 3b and the b, you can simplify those. You can add those. So we call the terms involving the same symbol a and a there, we call these like terms. So 2a and 5a are like terms, 3b and b are like terms. Whereas 2a and 3b would be unlike terms because they have different symbols. Right, so the way to simplify such an expression with a mixture of like and unlike terms is to group the like terms together. So let's do that. We have 2a, and the like term for 2a is 5a. So I'll put these together. And then 3b and b, so 3b plus b. So what I've done is that I've put the like terms next to each other. I can just rearrange them like that because we have additions, and if I rearrange the places, the addition will just give the same answer. Alright, so I've grouped the terms in A together. So now I can simplify 2A plus 5A. Just add the 2 and the 5 to give 7. And I can simplify 3B plus B, because we know that B means 1B. So we have 3B plus 1B. That's 3 plus 1, which is 4. 4B. So that we have just simplified the original expression by grouping and simplifying just the like terms. Now once we have reached this, we cannot make it any simpler, because we already have two unlike terms here and they can't be added together. So we can only leave it as it is. So we would call this the simplest form. Let's now look at multiplying and dividing expressions. Now if we have just A times B, we have seen this already. It's quite simple. I can just write it as AB. I can leave out the symbol times in between. Now things gets a little more tricky when there are numbers and signs involved. Let's start with the signs. If I have, say, minus 1 times A, right? Minus 1 times A means the same as minus A. So just to make this a little less abstract, look at an example. If I have minus 1 times 2, we know that minus 1 times 2 is minus 2. So that's really what this means when we say minus 1 times A is minus A. We have now a minus sign in front of the A, just like we have a minus sign in front of the 2 when we multiply minus 1 by 2. Now sometimes you would also see expressions like that. Plus 1 times A, that means the same as plus A. And plus A really mean just A. Right? So it's again an example. If you have plus 1 times 2, you can either call it plus 2 or just 2. Okay, now let's start multiplying two quantities that have signs. If you have, say, plus A times plus B, well, plus A is just A and plus B is just B, so this is just A times B, which is AB. How about minus A times B? Minus A times B, well, minus A means the same as minus 1 times A. Alright, so that's just minus 1 times A. And we know what A times B is. A times B is just AB. And the effect of the minus 1 there is just to give a minus sign. So that's that. If we have numbers, okay, let's try that. If let's say we have 2A times B. So 2A times B, 2A is just 2 times A and then you times B. So I can just leave out the bracket and it really means the same thing. Okay, now what if I have A times 2B? Well, that means the same as A times 2 times B. A times 2 times B. And when we have these three numbers multiplied together, I can rearrange the order and it's the same. So that still means 2AB. And what if I have signs? What if I have A times minus 2B? Let's be a bit careful here. A times bracket minus 2B is not the same as A minus 2B. Alright, it really means A times this. Now let's write that out a bit more carefully. So it means A times is minus 2B. And minus 2B means minus 2 times B. So that's what it really means. So there is no actual subtraction anywhere. We are multiplying by the minus 2 as a number itself. Alright? And since we can rearrange the order of the multiplying, let's do that. That will just give minus 2, just bring the minus 2 to the front. That's where we normally put a number in an expression, and that's the A from there, and that's the B from there, minus 2AB. So let's look at one more example. What happens when we multiply minus A and minus B? Now, in numbers, we know that if you have minus 1 times minus 1, we know that the minus and minus sign cancels to give 1. So in the same way, minus A times minus B, the minus and minus cancel, becomes a plus. So they cancel, and you would just have AB as the answer. That's right. Let's look at dividing symbols. If I have A divided by B, it's just A over B. We have seen this already. Now things get a little more tricky again if there are signs, there are plus or minus signs involved. Let's take a look at that. Now suppose I have minus A divided by B. Minus A divided by B. Now that really means the same thing as minus 1 times A divided by B. So it's like having three numbers here. Minus 1 times A divided by B. Now if I have a fraction like this, I can write that as minus 1 times a over b. That's what it means, the same as that. And if I have minus 1 times something, times the number a over b, I can just write it as minus of a over b. So see what happened to the minus sign here. In the beginning, we had minus a in the numerator. We have minus a on top. Alright? Whereas now at the end, we have minus a outside of the fraction. Okay? In the beginning, the minus sign is part of the fraction. Is on top of the fraction. We have just rearranged it so that the minus sign is outside of the fraction. The fraction is now just a over b. We have just a on top. So this really means the same thing. Minus a over b is the same as minus of the fraction. So in the same way, you can think about a over minus b. So in this case, we have minus b at the bottom of the fraction. Minus b is the denominator. If we can go through the same steps and find that this is really equal to minus of a over b. So again, we can have the minus sign outside of the fraction, and the fraction is just a over b. But we do have to be careful when writing the minus sign, especially when there are other terms around. Let's look at one more. What if we have minus a over minus b? Right, minus a is the same as minus 1 times a. Let's write that. Minus 1 times a. Likewise, minus b is the same as minus 1 times b. What we have now is minus 1 on top and minus 1 at the bottom. So we can use cancelling. Minus 1 divided by minus 1 is just 1. And we are left with a over b. In other words, the minus sign and the minus sign cancel when you divide, just as they cancel when you multiply. So that's just a over b. So these are some of the things which are nice to get used to. They're very helpful when you start doing questions. And what we have just seen here is that I've used cancelling when doing the fractions in algebra, just like we can do that when we have fractions in numbers. So let's look at a more slightly more complicated example, like AB over B. We can actually simplify this, make this look simpler by doing cancelling. Alright, so AB is really A times B over B. So in a fraction, if we have a number times a number divided by a third number, we can apply cancelling to simplify it. In this case, we have a B on top and we have a B at the bottom. So we have two same numbers on top and at the bottom. All we need is to divide each of these by B to get 1. Divide the B on top by B, divide the B at the bottom by B, and it will just be 1 and 1. So we have in fact cancelled off the B, and we are left with the A. So the answer for this is A. And once you are used to this, you don't even have to write it out in in this form with the multiplied sign, you can just do it directly there. AB over B, just cancel the B. Be careful though, as in algebra, it is quite easy to think that when you cancel the B, or when you cancel the number is gone, meaning you get 0. Alright, so it's easy to just replace the B there by a 0, and that's wrong. When you cancel the B, you're not really removing the number and getting 0. Alright, when you cancel numbers in a fraction, you're really dividing that number by something. So what you would get is another number. So in this case, when we say that we cancel the B, we are really dividing the B by B. So if I divide B by B, I get 1 there. If I divide a B by a B at the bottom, I get a 1. So that means that when I cancel the B, in this case, I get a 1 and not 0. Next, let's look at the idea of brackets in algebra. Let's say we have 2a plus b. So we have the bracket that contains the symbols a plus the symbol b, and we have a 2 outside of the bracket multiplied by this. So this really means the same as 2a plus 2b, meaning that I can multiply the number outside of the brackets by each term in the bracket. So I get 2 times a like that, and 2 times b like that, and then add them together. So just to refresh the ideas from numbers, this property is called the distributive law, and we can convince ourselves that this is correct by trying this out on some numbers. So let's try that. Suppose we have suppose a and b, suppose a is equal to 3 and b is equal to 4. So let's use our substitution method to calculate this. So the left hand side of this equation, meaning the 2 times bracket a plus b, is 2 times 3 plus 4. I have just substituted 3 into the a like that, and b, 4 into the b like that. Now on the right side, on the right hand side, I have here 2 times a, which is 3, and 2 times b, which is 4. You can check easily that these are equal. Alright? 3 plus 4 is 7. We have 2 times 7 on the left hand side. On the right hand side, we have 2 times 3, which is 6, plus 4 times 2, which is 8. And 2 times 7 is indeed equal to 6 plus 8. Both of them are equal to 14. So this is just to convince ourselves that this is correct, that it is really okay to multiply the number outside the bracket by each term in the bracket, like this. And we do this quite a lot in algebra. And because when you do that, the bracket is gone, we give this step a simple description. We call this step removing the bracket. Let's look at a slightly more difficult example. Let's look at 2 times 3a plus 5b. Right. Let's try removing the brackets. Now I need to multiply the number outside the bracket by each term in the bracket. The first term is 3a. So I need to multiply 2 by 3a. Let me write that down. 2 times 3a plus, and the next term is 2 times 5b. So I can simplify that. 2 times 3 is 6. 2 times 5 is 10. 6a plus 10b. So I have just removed the brackets. Okay, let's continue. Let's try this. 2 bracket a minus b. Now we introduce a minus sign now in the bracket. So if I now want to remove the bracket, I'll get 2 times each term in the bracket, so that would be 2a. The next term would be 2b. And because of the minus sign there, I'll have a minus sign here after removing the bracket. 2a minus 2b. Okay. Now let's take it one step further. What if I have 2 minus 2 times bracket a plus b? This time I have a minus sign outside of the bracket. Now please watch carefully. Having a minus sign outside the bracket is always tricky. In this case, you have minus 2 times a. When you remove the bracket, minus 2 times the first term, and you have minus 2 times the second term, so that's minus 2b. And these two terms should be added together. Alright? So let me just write this, put a bracket around them, just to be safe, and say that we want to add them. I can simplify this a bit. I'm actually producing more brackets there, which is confusing. I can now say that minus 2a, the bracket minus 2a is just minus 2a, and plus the negative of 2b is the same as minus 2b. So notice what has happened. At first I have a bracket with a plus b inside. So at first a plus b A and B are both positive symbols, right? A and B. Now after removing the bracket, the signs in front of the two terms in A and in B, the signs have changed from plus to minus. Let's look at another example. Minus 2 times the bracket of A minus B. Right. So we have minus 2 times A. That's 2A. And we have minus 2 times B. That's minus 2B. And again, I'm going to put brackets around it just to be very safe. Because we are going to have to either add or subtract these two terms. In this case, it's a minus there in the bracket, so I should have a minus there. Alright, now let's remove all the brackets. Bracket of minus 2A is just minus 2A. Minus of minus 2B. Well, minus and minus cancel, is like minus 1 times minus 1, which gives plus 1. So the minus and the minus cancel, and I would just get plus 2B. Now let's compare this with the initial bracket. So at first we have in the bracket A minus B, term minus term. After removing the brackets, we have minus 2A plus 2B. So the term in A was at first positive. After removing the brackets, it has become negative. And the term in B was at first negative, in the sense that it has a minus sign in front of it. After removing the bracket, that sign has changed to a plus. And this happens because the bracket was multiplied by a negative number. So when the negative number is multiplied by A, the sign of the term A changes. When minus 2 is multiplied by the minus B, the minus and the minus cancel to give a plus. So this gives rise to a rule which people sometimes talk about, which is that if you multiply a bracket by a negative number, or you can say if there's a minus sign in front of a bracket, then when you remove the brackets, the signs of all the signs in the bracket change, or all the signs in the bracket gets reversed. Let's put all that we have learned together and look at a slightly more difficult example. Let's try and simplify this. Right, so that's quite a long expression. It's got brackets inside. It's got numbers outside the brackets. Alright, it's even got minus signs. So these are the kind of problems that we are likely to get in algebra. And we really have to observe all the rules carefully about multiplying by minus signs and about removing the brackets in order to get this right. Let's start. First one is an example that we have seen before. Multiply the number outside the bracket by each term in the bracket. So first we have 2a plus, then we have 2 times 3b. Now 2 times 3 is 6. I can write down 6b. Next come the tricky bit. I have a minus sign outside the bracket and I even have minus sign inside the bracket. So remember, when you have a minus sign outside the bracket, then when you remove the bracket, the signs of the terms inside the bracket change. That's basically because you're really multiplying the minus sign outside the bracket by each term in the bracket. That's why the sign of each term in the bracket changes. So let's do that. We have minus 4 times a. So that's just minus 4a. Next we have minus 4 times minus 2b. Let's think of the sign first. We have a minus times a minus. That gives a plus. Yeah, that takes care of the sign. We can now worry about the numbers. 4 times 2. 4 times 2 is 8. And that is the b. So if you think of it this way, then you will get it right. In the next step, we want to simplify this expression. Notice that you have a and you have b in the expression in the different terms. So the way to simplify this expression is to group together the like terms. So let's take these out. We have the term in a here and here. So 2a minus 4a, these are like terms. And we have the term in b here and here. 6b plus 8b, these are like terms. So we can simplify the like terms. Now we can rearrange them and group the numbers, the like terms together. Or once you're used to it, you can just pick out the like terms directly. What I often like to do is to put a little tick or a little line below the like terms, like for 2a and minus 4a, I know that these are the right terms. So all I need is to look at these two terms and say, and add them or subtract them directly. In this case, I have 2a minus 4a. So that's 2 minus 4, which is minus 2, minus 2a. Alright, and for the b, the term in b, now I'll put a little mark there, which is a bit different from the mark that I use for the terms in a. So I have 6b plus 8b. And I simplify that by doing 6 plus 8, which is 14. So that's plus 14b. So that's the simplified form for this expression. So we'll stop here for this session on basic algebra. Thank you.